Hello.
Yes, sir.
Now it is audible.
You are audible, sir.
Yes. This is a last session somehow. Uh, then in the next session, we'll be mainly doing we'll collect your data for certificate registration. Uh, and then we'll also do one more thing that we'll collect the feedback about the workshop also. And then we'll do one short quiz around 10 to 15 minutes. ठीक है ना? It will have around 20 questions. It will be all multiple choice. It will be easy for you to attempt that. So it will these all will be happening around between 3 to 4 p.m. and finally from 4 p.m. we'll have the valedictory function. Okay. So let us start. Just to share my screen.
Sir, when the test will be taken?
It will be between 3 to 4 p.m. First, your data will be taken for the certificate preparation. Okay. All will come in the form of Google. All will come in the Google form. Then the second thing what we'll do, we'll collect your feedback, very brief feedback. So for these two activities, we'll give half an hour between 3 to 3:30 p.m. Right? And from 3:30 p.m. to maybe 3:45 p.m. or 3:45 p.m. to 4 p.m. something around that. I'll put that message on the group also, WhatsApp group. We'll conduct one short quiz. It will be very basic. You need not that worry that, and it will be multiple choice kind of thing. Okay.
Okay, sir.
Now, is it my screen visible to you?
Yes, sir.
Is it visible? So, you all of you know about first order system. First order system, all of you know. So whatever we have learned, so we'll do one small programming. It will have everything. It will have array, it will have graphs, it will have shift register, it will have express VIs. Okay. So suppose I first order system, if I describe, so what will be the differential equation for the first order system? Can I write like this? At tau multiplied by dy by dt plus y is equal to k, the static sensitivity k into x. Is it all of you are getting this? What is k? K is what? K is your static sensitivity. Okay. Now what is tau? Tau is your time constant, right? What is your y? Is static sensitivity and time constant are what? These are the system properties, right? What is x, y? Y is your output, and what is x? X is your input, right? Now consider you have to determine the output. You have to determine the output for the following inputs. That x input is given as input, and they can be of the following type. So generally, when you test any system, what are the inputs you take? Can anyone say that when we take any input, then what are the inputs we take?
So controls.
Not in a general that you have read about control systems na, in the course that
Sir,
what
an
kind of
impulse input.
impulse input. Okay, impulse is actually it is a pulse input only. It is
Hmm.
having very short duration. Okay,
Yes.
so that is one kind of input. So that then other inputs, what do you take? You take one square input, square wave step input. If there is a sudden change of input, then sudden change step, then that is a step input you take. That suddenly the input is changing from one value to another value, then how the system will respond, that you consider as a step input. Now if you take one square waveform, that is a set of step input, yes or no? That is a set of step input. If you take a positive, when the square waveform is rising, so that is a positive step when it is going from 0 to maximum value. And when it is coming from maximum to 0 value, then what is that is the step is called as negative step. That step is called as negative step. One second. Hello, hello,
Yes, sir.
everyone. Actually, I had to take one call of Dr. Gunjan. There is a one information for all of you that he will be engaging one session on the statistical measurement. Okay? There was some. He's also involved in some NBA activities, so now he has to reschedule that, and he has agreed to take that session. Okay? So that is very nice. That whatever we have promised, that we are giving you. Uh, what I am saying that if you'll see, could you see this? This suppose I draw one straight line. Let me draw one. You are. I'm sharing my that screen. Na?
Yes, sir.
So I'll draw here. I'll draw here one input. Just see that this this is called as a positive step. Could you see this value is 0, and this value is some amplitude A. So this is called as a positive step signal. Have you heard of this type of signal? Suppose there is a sudden force. Suppose there is a sudden change of the force. So is it how you will represent that? So for time t less than 0, for time t, this is the time t is equal to 0. The value of the force was how much? It was 0. And for time t greater than 0, how the force much became? It became to that A. Okay. Suppose one thermometer. Suppose the thermometer is initially at certain temperature, and suddenly you expose it to some higher temperature. So there is a sudden change from one environment to other environment. So that is called as a step input. So this is called as a positive step when you go from lower value to the higher value. Now, if I will draw another signal, if I'll draw another signal, okay, what is this? This is changing from A to, what is that? It is changing from A to 0. Okay. Suppose this is at time t equal to, this is the time t equal to capital T or capital T by 2 sometime. Okay. So what is this step is called as? Initially the signal was high and then it became low. Okay. So now this is called as a negative step. This is called as a negative step. Okay. Now if you'll see this total in this total, is it resembling something? The total, this input, this this is called as a pulse input. You got it or not? This is called as a pulse input. This is your pulse input. Now the pulse input, can you see, pulse input has two components. One is the positive step. This one is the, this one is your positive step. This one is your positive step, and this is a negative step. This is a negative step. Okay. So in order to know the system dynamics, we always calculate how fast the system rises from one level to another level. Suppose you apply a step input. So how does a fast signal will respond, and how does a slow system will respond? What is a slow system? What do you mean by slow system? Suppose you have applied one input like this. So how does a fast signal will respond, and how does a slow system will respond? Can you tell me how does a fast signal will slow system will respond? So just you see how I am drawing. This is the behavior of a, slow system. Ultimately, it has to catch the final value. Ultimately, is everyone is with me following? Not getting voices. Yes, sir, you are telling, you are saying that yes, you are following. Okay. Uh, okay. So I'll move ahead. So this is your slow system. Now, if another system is there, and that has a response of something like, suppose that has a response of something like this, then which one is faster? Which system is faster? Can you tell me which system is faster? the one which reaches the steady state earlier, that system is considered to be faster, right? Now there is one particular that quantity that determines the speed of response for any first order system, and that is called as a rise time. Rise time is determined as the time taken by the system to rise from 0% to 90% of the maximum steady state value that is called as rise time. Okay, so the system which will take a lesser time to go to the 90% and above range, it will be considered as faster, and the system which will be taking the larger time to move from 0% to 90% will be called as a slower. So this is one input that is called as a step input. Now there are other inputs also. So one we will see the step input is will see in the form of square waveform. Okay, square waveform will give. Okay, input I is a square. Then what can be? Have you heard of sinusoidal waveform? Why do you go for a sinusoidal that analysis? Why do you go for a sinusoidal analysis?
Sir, because any signal can be represented in terms of sinusoids because of the
Any
Fourier series.
Yes, any periodic signal can be represented as sum of that sinusoids and then of different frequencies that we know that. Okay. So that is one very important concept. Raghav, I think he is Raghav. So that sinusoidal response is one of the important. Then one more thing that if you want to know the frequency domain characteristic, if you want to know what is the frequency domain characteristic, whatever the signal I have drawn earlier, that was in the time domain, right? This was the time domain behavior. Now if you want to know the frequency domain behavior, why you go for frequency domain behavior, you see that which frequency components are the strongest. Have you seen the discrete plot of Fourier series sometime? Have you
Yes, sir.
plotted that at different frequency, omega, 2 omega, 3 omega? You had
Yes,
some
sir.
discrete vertical lines. Yes, you remember those plots? Now,
Yes.
A0 was what? A naught was what? That was the DC value, and the AN and BN were the coefficient of sinusoids. Yes, right. So if you'll see those things, so AN was associated with cos and BN was associated with sine. I think something like that. It will be like that. Okay. So now if you want to know which frequency components are really stronger and you want to suppress them, then what you have to know, you have to go for a frequency domain analysis. You have to see that which because you want to remove the undesired one. So the sign is another important the signal. And the third signal is quite important. Let me write sinusoid. And the third signal component is have you heard of ramp signal? Have you heard of ramp kind of signal? Suppose a signal is changing at a linear rate. What do you mean by linear rate? With every input, with every increase of time, the signal is the input is rising at a constant rate. So how you show that? How you plot that? Suppose so is it a ramp signal? Is this a ramp signal? Yes or no? So how you determine this is t equal to 0? So this is t equal to 0. So this is called as, this is having positive slope, right? This is having positive slope. Okay. So this is called as a positive ramp. This is called as a positive ramp. Then it can even go to certain saturation value. Then it can go to even some saturation value. Okay. This is called as saturated ramp. Okay. So if the input is increasing at a linear rate, okay, then how the system will behave? That is another one thing we determine. Have you seen some function generator, by the way, in your laboratory?
Yes, sir.
All of you must have seen the function. What are the typical standard waveforms there in that?
Sir, square wave, sine wave, triangular
If
wave is also there.
this only three waveforms will be there. If you'll see na, in the
Mhm.
standard function generator, these three waveforms will be definitely there. What the square waveform, the sinusoidal waveform is for what? To do the frequency domain analysis, right? The square waveform is why? To know the system behavior in the time domain, how fast the system is responding to sudden changes in the input. And then the third one is a triangular waveform. There it says that how the system is responding to a linear change in input at a positive rising rate or a negative falling rate. Okay. You have a, this is the positive ramp, and this can be one, this can be regarded as a negative ramp. Just see, this will be regarded as a, I think there is not, this will be regarded as a negative ramp, this will be regarded as a negative ramp, right? This will be regarded as negative ramp. Okay. So that this is another thing. This will have the third one is your triangular waveform generator. Okay. So we'll what we'll do, we'll test our system for these three. So triangular waveforms. Now, can you tell me that what will be the control and what will be the indicator in this? So you have got my system description. You have to design a first order system which is given by tau dy by dt plus y is equal to k into x, where k is your sensitivity, static sensitivity, the tau is your time constant, and I think time constant you must have read na, about RC circuit in the 10 plus 2 even. You remember the RC circuit in your 10 plus 2? That how much time taken by the capacitor in one time
Yes, sir.
constant,
Yes,
right?
sir.
So in one time constant, how much it rises? It rises by 63%. It rises by 63% of its final value. In two time constant, it rises by 85% of the final value. In three time constant, it rises by 95% of the final value. And in four time constant, it rises by 98% of the final value. And in five time constant, it rises by 99.5%. It is almost. Okay. And if you remember the standard equation, that was that v into 1 minus exponential raised to power minus t by how much? For RC circuit, how much it was? R into C. You remember this equation? V, the voltage across capacitor is this. Yes or no? You remember this equation from your 10 plus 2 I am saying. So V was what? V was the input voltage. Certain voltage you have applied from 0 to V. RC was what? RC was one circuit. RC was one circuit. Okay. RC was your one circuit. This is your R and this is your C. This was your R and C. Okay. This is your RC circuit, right? And here you are giving the input. Here you are giving your input RC, right? Yes. Okay. So if you'll RC is known as what? RC is known as what? RC is known as time constant. RC is known as time constant. Now coming back to our problem. Now please tell me what are the inputs here? What are the controls? Now please tell me for the system design what are the controls and what are the indicators? Please tell me what will be the controls. The system characteristic will be is determined by what? Static sensitivity and the time constant. These will be controls. Yes or no? So K will be a K. So K will be a what kind of control? Numeric. And tau will be what kind of control? Numeric again. Right? Then input. Input, how you'll what you'll do? You will select one type of input. Type of input. Type of input. Okay. Type of input you will be choosing. So this will be what? Type of input will be what? Will be to numeric. Will it be numeric? Numeric. So K is numeric. Tau will be what kind? Numeric. And type of input will be what kind of? It will be type of input will be what? It will be enumeration kind. Enum. Okay. Now the input will have what? Any input has what? It has a amplitude and it has a frequency, right? So the type of input is enum, but the amplitude, the amplitude, the amplitude A is nothing but the amplitude A is your again numeric kind, numeric, and your frequency, frequency F is what? Frequency F will be what kind? Frequency will be what kind? This will be also numeric. What will be the indicator? What will be the indicator? Can you tell me? Indicator. Where you will have indicator? Indicator will be only one, the output. Is it everyone is following? Everyone is following this. Indicator will be what? Indicator will be the, suppose, waveform graph. Indicator is like a waveform graph for Y. Okay, for Y. Okay. So what we'll do, we'll keep that system description. Okay. Now let us make something. Let us go to silver, numeric. Okay. Let us say this is one your what you want to call static sensitivity. Static density dt. Okay. Let us make a copy of this. That will call it as a time constant. Time constant. Okay. Let us name it as k, and the time constant, let us name it as.
Sir, we should do it along with you, right, sir? Now.
Yes, that's what that I was feeling very that no one was responding. Can you start along with me?
Yes, sir, we will.
Uh,
Both are two numeric controls, right, sir?
yes. So these are the system description. Okay. Now, so we have put the system description. Let me little bit this, this put it nearby. Okay. Now it is fine. Is it everyone has done till here? Now tell me what are that I have put two controls right now, and what are the other controls? Other control will be one type of input. So I'll go to silver, I'll go to ring and enum, I'll go to enum, and I'll put type of input. Okay, I'll put here the type of input. Type of input. Everyone has done up till this. Should I repeat how to do? Go to front panel, right click, go to silver. Okay, I can pin it also. That Vineet told na to pin that. Okay, so that then go to silver, go to numeric, and go to control. Right, numeric control. Again, for a time constant, you highlight that, you select that particular control, then what you do, you with your left hand press the control button and drag it like that. Okay, could you
Sir,
see?
actually, I have placed both of them from this modern palette, sir. Means any problem, sir?
No
Or
problem, no problem. Only that he said, na, it will look only that it looks a little fancy, but there is no problem in that. Okay.
okay, sir.
Actually, some problem will come in the actual deployment where some you want to keep the size of the other things very minimal. So there sometime it comes as a problem. You'll select you would like to give that as a minimum space. Okay. Anyway, that you have done, Naveen, till here static
No, sir.
sensitivity.
Actually, that
Ah,
enum placing, I need to means repeat the steps, sir,
yes,
please.
that right click there, go to silver, then on the row number 3, ring and enum, and then go to enum.
Yes, sir. For this also, I was just directly going to this. Yeah.
No problem. This also enum. Okay,
Uh,
that
yeah.
also you can do. Okay, so
Yes.
that we have put. Now the type of input we have determined. Let us go to its properties. Let us go to properties, then go to edit items. So what are the inputs we want? Sine. Should I put it sinusoid? Sinusoid. Okay, that is one. Then insert. The second one is your square. Insert, and the third one is your angular. Let us make sinusoid as number 1, move up. Let us make the sinu square as number 2, move up. Okay, so this is the order you have done. Everyone has done this.
No, sir. Just give me a minute.
I'll again tell, I'll repeat. On the, you can go to properties on either side, either on the block diagram or on the front panel. Suppose on the front panel, I'm hovering my mouse. You just see, I have hovered my mouse. So it is, now it is highlighted. Okay, there I have clicked the properties. It may come to appearance or data type by default. Then go to the edit items.
Yes, sir.
Can I get a quick review, that confirmation from everyone that they are with me? Raghav, if you can,
Yes, sir, done.
yes, done. Because I'm not seeing the chat because I'm here on the other window, since I'm sharing my screen. So I'm there. So okay, done. So now what we'll do, now we'll create the amplitude and frequency. So go to silver, numeric control, silver, and then what we'll do, we'll select the amplitude. So here we'll select the amplitude, right? And finally we'll select its frequency. We'll select its frequency. F, amplitude, in, right? Now I'll put all these things within a while loop. I'll put all these things within a while loop. So go to the block diagram. So we are done with the front panel, basically. Now go to the block diagram. Right click there. Go to the block diagram, right click, and go to structures, go to while loop, and place your while loop such that it takes all these values in its.
Means, can we use that control user?
you can no need to use right now Control U, because Control U should be used at the end only. Otherwise, you will be doing. Sometime you would like to place the things as per your need also, na?
Yes, sir.
Okay, so that. Um, okay. Now here I would like to tell there is some tools. View, then there is something edit.
Abhilasha?
Search. Okay. There is a right click on the here. Can you see one decorations?
Yes, sir.
Decorations, can you see all of you? Right click on the front panel. Okay. Right click on the front panel, go to decorations. Can you see all of you? You can also go to
Yes, sir.
here, silver, and then you can select one of the decorations. Suppose this is the decoration I am selecting. So I can actually put everything. What I'll do, remove this for time being. What I'll do, I'll put the decorations. Okay, and then I'll put all these elements on in it. Properties. Oh, there is. To make it visible, but decorations. That is not. Color. Control background. Actually, here we can select the particular color for this. We can unable to do that. 1 second. Anyway, that yeah, this decorations we can use. I think I should be able to put that decorations. Properties. Color. Okay, anyway, I am unable to do that, but you can use that decoration. Actually, all these na, will come into that. Okay. Anyway, for time being, that will not concentrate there. Now, our main part is to now generate one express signal. So, how we have done that? Go to the block diagram, then control the space bar. Then what is that? Simulate signal. Everyone has done this.
Yes, sir.
Okay, everyone has done this. So simulate signal is this. Okay. So we'll put the number of. We can make one case structure here. We can make one case structure here. Suppose I have made one case structure. I'll put this inside. Okay. I'll make one case structure, and the type of input I can connect to this case structure. Is it fine with everyone? How many cases are showing up? Two, na? So one add case after. Add case after is the triangular one. Okay. So let us do further. First the sinusoid one, and then we'll replicate the same thing to elsewhere also. So frequency and amplitude we'll have to select here. So if you
Sir, actually, we are not changing anything in that. What is this? Simulate signal, right, sir? Configure simulate signal.
we'll give this to that amplitude. We'll give the amplitude, and we'll give the frequency also.
Okay, sir.
These two inputs we'll give. Okay. Everyone has done that. So can you see that presently your is moving? That waveform is moving because the number of samples is not that a multiplier. Okay. Suppose I make it 10 hertz. Let's see, it has become stationary. So suppose it is 1, it is the number of samples. Suppose it is, suppose I'll take 500 samples per second, and the total number of samples will be 5000. Okay, integer number of cycles. You take the integer number of cycles, right? Just see, everyone has done this part.
This is only for sine. Sorry.
We'll replicate the same thing others also.
Okay.
So please repeat the same step.
I'll repeat again. One had that controls that is sensitivity, time constant, time or type of input. I'll remove this. Remove this also. Everyone is still here. So everyone is having till here.
Yes, sir.
Yes. Now make one case structure. Make one case structure. So go click somewhere, anywhere. Then right click there on the block diagram, go to case structures, and then you put inside the while loop. You put inside the while loop, and you connect the type of input to the case selector level. You connect the type of input to the case selector level. How many cases, how many, can you see this case selector? Now can you see this selector level on the top? How many are showing up? It is showing only by default 2. So when you have more than 2 cases, what you'll have to add it manually. You'll have to add it manually. So I will put add case after. So it has come. Now you just see it has come all the 3. Is it everyone is still here? Sinusoid, square and default. So let me begin for sinusoid. Let me begin for sinusoid. Okay. Within the case structure, put right click, otherwise put control spacebar, quick drop, let us. So then you type simulate signal. That will put one express VI that will behave like a function generator giving us the sine wave, because we want that sine wave somehow. So double click that and put it put it inside the sinusoid case. So now could you see this is moving? You make this as the integer number of cycles. Could you see this has stopped integer number of cycles? It has stopped, right? So the 10 hertz is a big that it will. I'll put 1 hertz as the, and then I'll put 500 samples per second. Okay, per second, and then the total number of this will be 5000. This will be, I'll put it as 5000. Okay, so actually I'll take the total number of cycles to be 5000. Okay, total number of samples. So I have configured my signal. Now what I'll do, I'll drag it down. Can you see that so many options are there? That type of that I have chosen sine, same as sinusoid. The amplitude I'll just connect to the tunnel to this amplitude, and the frequency I will just connect to this, to the frequency. Is it visible to everyone, this?
Sir, actually we should deselect that automatic and give 5000, right, sir?
Which one?
Means while taking the editing that simulate signal dialog box.
Just
Actually,
I have taken to be, this is the number of samples to be displayed actually. The number
yes, sir,
of
means
will be,
automated checkbox was actually ticked. So
no problem, you can keep that also, but I have what we have done, we have taken the number of samples to be displayed actually. Okay.
okay, sir.
Okay, so total how many cycles will be there? It will be showing 5 suppose you have 500 samples per second, and if you want to display up to how many seconds, this will display up to 10 seconds, right? You have the 5000 samples na? Okay, so it can display up to 10 seconds, right? Anyway, we'll go further. Now the next thing is you'll have to first thing here, you come here, this system. Now I am at front panel. You just see this system, I have the differential equation. Yesterday or day before yesterday, I told you that what was the definition of the differential derivative. This I can write. So just see tau into dy by dt. What I can write? Dy by dt. I can write dy by dt as yk y. Suppose the present value is y minus the previous value yk minus 1. I can say y1. Okay, and this divided by the term delta t dt. Is it this definition of derivative is fine if delta t is very small, dt is very small? So this will resemble plus y is equal to k into x. Sorry, capital K into x, right? Where these are the sampled values, right? These are the each sample values for each sample. Okay, you know now that the difference equation form that you can that numerical analysis if you'll do. So what I am doing, I am discretizing it. Okay, so this is that thing I have done. Then what if I will solve this? If I'll solve this, then what will be the value of y will be coming to me? If I'll solve this, then what will be the value of y that will be coming to me? Can you tell me? Can you tell me the value of y that we need to have? That will be uh, capital K into x into dt, okay, plus tau. I'll put star in between for multiplication into y1 divided by dt plus tau. Is it coming? So just see that if you know the present input sample value x, and if you know the previous output value y1, and if you know the system constant k and tau and dt, then you can find the value of the present output. Then you can find the value of the present output. Is everyone is getting this or not? Is everyone getting this?
Yes, sir.
You have got this, right? So what we'll do now, the next thing what we'll do, as yesterday we have seen, we'll first what we'll do, we'll convert from dynamic data type. We'll convert from dynamic data type. Just you place that convert from dynamic data type. Hello.
Yes, sir.
So you have right click there. Sorry, not right click. Control space bar. Then you put convert. And you see, I have put convert from dynamic data. It has come. Is it visible to everyone? I have substituted here, convert from dynamic data. ठीक है?
You have taken convert from to or convert to.
Sir, you have taken convert to dynamic data type.
अच्छा, convert from I have to take ना? Yes. That's all. Convert convert to
Sir, press F, sir, means by deleting T. Convert from dynamic data type.
ठीक है? Now
Yes, sir.
here you will select the single waveform. Here you will be selecting the single waveform. Since we are dealing with the single waveform, na? ठीक है? ठीक है? Now you connect that. Got it? Everyone has done that?
Yes, sir.
Now put one more component, that get waveform components. Control spacebar and then put get waveform components. Could you see this? Okay. Now you drag it like this. So what is y here? What is y? Can you tell me what is y? What is dt and what is t naught? T naught is your timing information, right? T naught is your timing information that will be used to synchronize two signals, right? And what is dt? dt is your sampling sampling interval. dt is your sampling interval. And what is y? Y is nothing but your amplitude of the sample. Y is nothing but your amplitude of the sample. Now can you tell me, this sine wave that simulates signal is a source, right? So what this y will give you? What this y will give you here? That will be nothing but xk, right? That kth input sample it will give na y. What it will give you? The
Okay.
kth input sample it will give. Okay.
Sir, actually means what we should search in that quick drop, sir, for this I did not get the.
Get waveform components. Control H. Get waveform components.
Okay, sir. Get waveform.
Control spacebar and write get waveform components. Have
Yes,
you
sir.
done that?
Got it, sir.
Naveen, you have done that previous one, that convert from dynamic data.
Which one, sir?
The previous one, convert
Yeah,
from
yes, sir. Yes, sir.
that you have done.
Yes, sir.
Now you take this one, get waveform components.
Yes, sir. Done, sir.
Done.
Yes, sir.
Now what we'll have to do, we'll have to uh, find out all these values for different samples, right? For a if you want if yeah, the different samples will look continuous when if you find out the values of the output for each one of them, right? So what we'll do, we'll make one for loop. We'll make one for loop by right clicking within the case structure and then making this for loop. Okay, and the number of iterations we'll put here, create constant. The number of samples we are taking now, 5,000
Yes,
in
sir.
this
Yes, sir.
simulate signal. The same number of times we'll run this for loop. The same number of times we'll run this for loop. And we'll connect this to these. The two only will connect. We'll connect two only. Now, could you see that by default y is an array? Yes. When you are connecting it to for loop, then y is an array. But what you are interested for each for each input sample, you are interested in one particular value, right? So what I'll do, that we will put that disable indexing. We will put disable indexing. Otherwise, no need to that keep disable that enable indexing. Actually, we want one by one. Na? Keep enable indexing. Keep indexing enabled. Okay. Now, actually, what we have to do, we have to implement. Can you see this formula we have written here? Y equal to k into x into dt plus tau into y1 is equal to dt upon tau dt plus tau. This we have written on the front panel. This we will have to implement. Now, in order to implement that in the LabVIEW is a software you can call the MATLAB also, but MATLAB should be installed there. MATLAB node you can call. So what we'll do, we'll call a formula node. Put control space bar and then search for formula node. Can you see? This is one new thing. I think this you should see once. Just see. Click inside the somewhere. Right click on the block diagram, some empty space anywhere you can keep. Click on the, not on the boundary of any uh, terminal or on the node function node. Okay, on any blank space you click on the right side, put control space, control plus space bar, then put formula, then this formula node will come, and you put this formula node within this. You put this formula node within this. Done. Everyone has done. Then what I'll do, within this node, I will write the same formula which I had written here. What is that formula? Y is equal to Y is equal to K. No, there should not be any space. K into X into dt. Then I'll keep it. This one I'm evaluating plus tau into y1 is another variable so this is the numerator. This is the numerator part. I'm putting this inside the. Now let me make it full screen so that you can see better. Then divided by how much was there? Tau plus dt, and then put one semicolon. Put one semicolon. Right. Now, have you done this till here?
No, sir. We are typing the formula. Just a minute.
Yes, I'll wait now.
Yes,
Now
sir.
I'll wait. The motive here is for each input sample, you find out what is the output value. Okay. Now, if you take the large number of samples, then what will happen? The result will be looking continuous, right? Have you heard about that difference between integration and summation? If you will take infinite number of summation, then it will become a continuous. Yes or no? So anything by default it is a discrete, but if you take the large number of samples, then it will become almost continuous, right? Kindly all of you make your this full screen.
Hello.
Yeah, Raghav.
So actually, my network just got snapped and I was disconnected. So
Yes,
can you just
I'll again repeat. Meanwhile, others can do.
yes, sir.
Have you put this
Sir, just a
controls?
second, sir. It's still loading. Your screen is not visible over here. Just a second, sir.
Controls have you put?
Sir,
Sir,
I am
I have
actually
a hack, sir. I think you can copy paste that one in the chat box. That formula means
Uh, I that I'll do that. That is
means just a simple solution, but I
That
think it,
also I have done. Okay, but if you
yes,
are using some other term, it will be same. It has to be same. You have to use. Okay. Raghav,
Yes,
uh,
sir.
do you your front panel has this static?
Sir, I am at the stage of that formula node stage.
So I'll just explain this. This nodes you have, the terminals you have, the controls you have, all the controls, and then you have made the case structure, right? You have made, then simulate signal also you have made, and then that convert from dynamic data you have made, and get waveform components you have made, right? And then you have made the for loop, and then you have, now you are writing in the formula, right? Formula node have you created? Raghav, have you created formula node?
I think there is a network issue on their side, sir. I don't know.
Okay, so let him join again. I'll explain to him. There is no issue there. I can again explain to him.
Yes, sir.
Have you done till here? Now, just you see, now the formula node has certain that some this y is your return value, right? And what are this k, x, dt, tau, y1? They are nothing but your input values. Okay. So now right click on the formula node periphery.
Yes, sir. Continue, sir.
So can you see there is one add input here? So click on the
Just a
add
minute.
input. So I will take one add input as K, capital K. The same thing what you have written inside the formula node, the same letter you'll have to add. The same, whatever you have written within the formula node, the same variable you'll have to name it here. And then we'll add another input, and that is nothing but tau. Okay. So these are, okay, these are my two, that k and tau. Then I'll add another node, then that I'll call it as another input, I'll call it as x. Okay. Then I'll add another add input, then I will call it as dt. Then I'll add one more.
Hello.
Yes, Raghav,
So I'm back online.
you are back online.
I've just placed the formula node. After that, I don't know what to do.
Yes, formula node that you have put within the for loop.
Sir, within the for loop, I've placed the formula node and it's blank right now. So,
Now you double click within the formula node within the,
okay, sir.
and then you write the formula.
Okay. The formula that we wrote over there.
Yes,
Okay. Okay, sir.
you have written.
So
I
you
have
can just copy it from the
Yes, you can copy it also.
front panel.
Now come to the formula node, and on the outer periphery you right click.
Okay, sir.
Can you see one add input is there? Add
Yes,
input
sir.
and add output.
Yes,
Just
sir.
see, this is a formula node. The y, that is y equal to, when you write something, y equal to fx. So all the f of x1, x2, x3, x1, x2, x3 are what? They are the input variables, independent variables. Okay. And what is your y? Y is your dependent variable.
Dependent
Why?
variable.
ठीक है. So in this equation, what is your output? Your
Y.
output is y, and what are your inputs? K. Static sensitivity is your one input, your tau is your another input, your input samples x are the another value, your that sampling interval dt is another input, and your previous output is your another input. Is it
Yes,
fine?
sir.
And
Yes, sir.
what is your output? On the other side, I'll put, I'm following the nomenclature. My output is y. My output is y. Right. Now what I'll
Yes,
do,
sir.
I'll connect one by one. Just see. I will take this. Just see, I'm taking the static sensitivity. I'll pass it to the first this your K structure. Then I will take it to the
For loop,
loop, and then I will
connect to
connect
K.
to K.
Okay,
Can you see it
okay,
is
sir.
taking a single value?
Yes, sir.
Then I'll do the same thing for tau. I'll I'll take it here. I'll take it here. I'll take it, and then I'll connect here. Can you see?
Yes, sir.
Now x has to be connected to what? X has to be connected to this y. Can you
Capital
see
Y.
this? Yes, that is actually, this will give you the indexing and the samples each for each sample wise. Na it will give. Okay, and dt you will have to connect to what? To dt, that is sampling interval. Now the thing is that we'll have to find out y1. That we'll have to find out the y1.
Sir, just give us a
Sir, we can
minute.
use shift register over there.
Will
Right?
use shift register. Ha Naveen.
No, sir, we are connecting. Just give us a minute, sir.
You are connecting. Yes. Everyone is here till with me. Everyone
Yes,
is
sir.
here. This example I have taken so that you will have all the concepts summarized also. So that is why I have taken this example.
Yes, sir, done, sir. Till this one.
Then y is also there.
Yes, sir. Y is connected to X and dt to dt.
Yes. Now on the for loop outer periphery, you right click on the for loop outer periphery, you right click and you put add shift register.
Okay.
Done.
Yes, sir.
Now first you connect the output of y, that formula node y na, to the right shift register.
Okay.
Actually this you should follow, otherwise if you will connect the left shift register first na, then there will be certain errors may come. Okay, then you will have to reconnect. Always you will have to connect the right shift register first. Okay, so this is giving you what? The right shift register is giving you y. Okay, the sample y value. So what is this left shift register will give you? The previous sample value. So this has to be connected to y1. This has to be connected to y1. And this I can initialize with 0. This I can initialize with a 0 constant.
Yes, sir.
Okay. Now let us take one more value here, and let us take it out. Okay. Now what we'll have to do, we'll have to now we have made everything. Now what we'll have to do, we'll have to get the, now we'll have to combine this actually. Okay. Now we'll have to generate the output. So what we'll do, control spacebar. Now you put it was this was what, this was control H was what, get waveform components. So this will be build waveform components. Build waveform. Okay. Build waveform. Okay. This attribute is your dt and this is your t naught, right? So this y, this is your y, right? This dt is same, the sampling interval, and this t naught output of input, it should be connected to here also. Everyone is here. Done till here.
Sir, actually means what is this? This you have taken, sir. What is that, sir? Means
Build waveform. Now with each sample, with each sample, what you would like to place those output samples one after another.
yes, sir.
So that earlier what we have done, get waveform components. So we have discretized it. Each sample we are taking as input. Now for each input sample, we are calculating the output, right? We are
Yes, sir.
calculating the output and then we are building this waveform.
Means what's the name of that, sir? How did you get it? I missed it, sir.
Control the space bar, then you
Yes,
put
sir.
build waveform.
Okay, sir. Just a minute. Yes, sir. Remove that quick drop window.
Done.
Yes, sir.
Now you connect the output of y here to here. And this I'll remove it and I'll show you. I'll connect here to here.
Why? Okay.
Then connect dt of build waveform to the dt of get waveform components. From outside you can take from inside also, but there is no need.
Yes, sir. Means if we just connect the dots, it will wire itself. That
It wires automatically. Then
yes,
you connect the T naught also of get waveform components and the build waveform. I said that it will synchronize, that timing informations are there here for synchronization.
yes, sir. Done, sir.
Done.
Yes,
So
sir.
now what, since we'll be displaying both, what we'll do, we'll build one array. So control space bar, then we'll put build array. So since you would like to display the input and output both, so in the array, one will give for the input output and the other one will I'll give for input. Can you see that how I am connecting?
Yes, sir.
Okay. Then you take this out of the case structure. Then here you can create one indicator, not indicator. I can have one waveform. I can have one waveform generator. Control graph waveform graph. Let me. I'll put here for time being. I'll just make it downside. Make some space for me. And I'll put them here. Okay. Now this I'll put it here and then I'll connect. Done.
Wait there.
10 more minutes. All of you kindly that be with me so that we can complete this.
Yes, sir.
Done. Now can you
Yes, sir.
see there is a small that white that groove is coming on the case structure, that right side.
Yes, sir.
Why that is so? Because all the cases have not been connected. All the cases have not been connected, right? So this we have done only for sinusoid. So what we'll do, this will take as it is. Can you see that I'm selecting the total? Can you see how I'm selecting?
Yes, sir. For it is the entire case structure, right, sir?
Means I'm selecting all the components inside that.
Yes, sir. Yes.
Could you see that I have now everything is getting highlighted in within the case structure? I'll put Control C. Control C
Okay.
is for copy.
Okay.
Then I'll go to the next square
Yes, sir.
and I'll put my cursor, I'll click in the middle.
Okay.
Then I'll put Control V.
Yes, sir.
Now don't click anywhere. You have to be little careful. Everything is highlighted. So just you little carefully drag it so that you place it accordingly.
Yes, sir.
Okay? So that it will be easy for you to connect everything. Now just see this has to be K. This I have connected. This has to be tau. This I have connected. This has to be amplitude. This I have connected, and this has to be frequency. This I have connected. Yes, and this has to be output. Sorry. Done for the square wave also. I have done. Now what we'll do here in the simulate signal, I'll go and I'll change the square sign to square. This everyone has done this.
Just change sign to square and nothing else.
Yes, nothing else. Other things we let it remain as it is. Okay. Now go to the next triangular. Again put control in the middle. You put the cursor. Actually, where you put, if you'll put the cursor here na in the corner, it takes that as the pasting value. Okay, so you put in the middle your cursor. Click on the middle and then put the control V. Then you'll see that your copy paste is almost aligned. And then you little bit you align it your this your pasted result. Okay, so everything is getting highlighted. Could you see? And then you connect all these things carefully. Can you see how it is easy? That if you take little care, then it will be very easy to connect. Sorry.
Yes, sir. All three are ready, I think. So. Sir, actually, we can't zoom in and zoom out in the block diagram.
Now you just see it will be completed now. Now it is completed.
Yes, sir.
Now it is completed. Uh, this is done. This is done. Still some error is showing. I think this we have to stop this while loop also. So in the, can you see the stop button at the right loop condition at the right corner down? So here
Yes, sir.
you put create control and put one stop button. Can you see that as broken line has vanished?
Yes, sir.
That is stop. So this is here and this. This decoration I will send you that how to do na by in the WhatsApp chat. Somehow I have missed today. I had practiced that. Only this I am able to do that. Only the problem is that it is becoming opaque. It should be transparent. So that is one problem it's coming. Okay, and then here I will okay, this is a square, that is right. Then I'll go to triangular. Here I'll change it to triangular. Okay, then I'll click it OK. So should we run now?
Sir, actually, I missed the last step, sir. Means you just changed something. I didn't.
I changed in the triangular. Go to simulate signal,
Okay.
and then you select the signal type as triangle.
Okay, sir.
Okay, so now you can just verify that in the case structure of triangular it is triangle. In the case structure of the square it is square, and in the case structure of the sinusoid it is sine, right?
Yes, sir.
Everyone is getting okay, let me, I click there. Everyone is getting that run button, continuous run button. That is there any broken arrow?
Actually, it is broken for me, sir.
uh, you have connected to some error or something? Just see by mistake. Can you share your screen? I'll see.
Yes, sir. I will share the screen. Just a minute, sir. Sir, is it sharing? Can you
Yes,
see that?
yes, I'm able to see. Can you show me the make a yes full screen? Triangular. Can you double click to this frequency
This one, sir?
uh, on the wire?
Click on that broken arrow. You will see the what are the errors are there. Click
That
on that broken arrow. See where it is. Double click on the formula node and everything, and you'll get to see what is the error. Oh, the formula is incomplete. Actually, that's the error. Expand
why?
the formula node window. Expand it. No, it doesn't
Uh,
seem incomplete. Then what is the error?
uh,
Sir, actually means it was in a sine mode. I changed it to triangular, but even after changing
that
means
is not the actually
That
the
is not
error
the
is in
issue.
formula.
Because you have written semicolon. So do we
No,
have to write?
semicolon is there. Semicolon is there.
Okay.
I can see the semicolon.
Tau plus dt is there. Block diagram. Error on I think you have written that first bracket you have given in this that parenthesis or that what?
First bracket.
yes, sir, it is a parenthesis.
Make it full that y1 x k is your small. Just see k is your small. It should be capital.
Oh, in
Down.
the input side. In the input side. In the
Okay, sir.
input
The
side, you have written small k instead of capital K. Your formula requires capital K.
and change in all others.
Uh,
Others
Now,
also go to
changing the other three cases also.
square. Go to square and that also.
oh, okay, sir.
It has come now, na?
Yes, sir.
Yes. So that nice. You must be happy, Naveen.
Yes, sir. It is completely case sensitive, sir.
Yes, it has to be case. Some otherwise, how they will differentiate? Because these
Uh,
are the two different users they use na sometime.
yes, sir. Sir, instead of changing all these inputs into the capital K, means what if I had changed that capital K in the formula to a small
So
K, sir?
that also you would have to change in all the three. That it's same thing. That whatever you keep in the formula, the same notation you'll have to keep here.
Okay, sir. No, sir. Actually, all the three Ks were in smaller case, no, sir. So I just asked.
Means I think inside you had written the formula with capital K only in all the three cases. So you could have changed there a small k either in the formula, or you could have changed the notation here capital K as to the add input.
Got it, sir. Means I should change that K in all the three formulas also.
Uh,
Yeah, it's both the same only, sir.
Now
Input.
can you give my screen back?
Stop sharing. Yes, sir.
Now is my share is I think I have to share again.
Yes, sir.
Okay, that I've done. Now just something I wanted to say that now it is everything is fine, right? Now you just see here that is static sensitivity. Suppose I want to make this by default it takes 0, right? Suppose I make 1, right? And suppose I want to that is static sensitivity is 1 for most of the system. So what is 1 actually? If you, what is 1? Suppose if you give x as input, and if you get y equal to x, the same output, then you call that system to be perfectly fine. It is taking the same input, giving you the same output, right? And if you get 2x as output, then what you call? You call it as amplified by factor of 2. Yes or no? And if you get 0.5x as the this, then what you call it as attenuated. So if you see one resistive network, then the output are always attenuated. What it will do? It will attenuate the input. Okay, the output is attenuated inputs. Okay, and what a amplifier they did do? They amplify the input. Okay, so ये तो मान लो कि for the best of the system, static sensitivity is taken as 1. Now if you run your present program, na, it takes 0 as the default value. Can you right click on this? I have written 1. Then you right click on that on this control. Okay. Then go to data operations. Everyone is following me? What I
Yes,
have
sir.
done? I have done, this was 0. This was 0, right? Static sensitivity was 0. I have made it 1. Okay. Then I have right click there. Then I am going to data operations. If I'll put reinitialize to default value, what it will become? It will again become 0. You'll see, you just see. It has become 0 now.
Yes, sir.
Now what I'll do, I'll make it 1 and I'll make this as my default value. Make current value default, then it will remain so. Suppose I made it 0. Okay. And then I will say reinitialize to default value. It will make it 1. Why?
Means we are actually fixing the base points in a way.
You are making your initial my default static sensitivity to be 1, right?
Yes. Yes, sir.
Similarly, what we'll do, we'll do the same thing. Just I am not doing that. I am showing for the time constant, and let us have for this, and frequency also let us have as 0.2. Okay,
Sir, right now we have fixed the 1 as the default value, right, sir?
which one?
Static
For
sensitivity.
that I have shown you that time constant present default value is 0. So let me fix that also. Make current value default. Make current value default. Make current value default. Actually, what happens, when suppose you have run all the program, right? And if you close that program, if you close the lab view, and when you again restart the lab view, you reload your program, right? So
Yes.
it has to initialize these controls. So the controls will be initialized to what values by default? It has to give one value now. Before you pass on any value, the program also has to load some default value. So that default value will be what? That default value either by default that numeric it's 0 for program. It is very easy for the software to initialize everything to 0. That is what we have learned in the literature also. Yes or no?
Yes, sir.
But if you want some specific value to be there forever, you want that value to start from 1. So you keep it 1, because in a large system, suppose you have many components. So how many times you'll go and change the values of control? You'll reload the controls.
Yes, sir. It would be a problem, sir.
It will be annoying only, na. It will be, you'll
Yes, sir.
have to keep repeating the same clerical job. then can you work on the development? You cannot work. So what we have done, you'll see that if you'll restart this, then it will load these values only. Okay, once I have made this as default. So let me now run this. Now can I make it little bigger so that you get all. Now just see, this is sine, this is triangular, and this is square. Can you see the square? Is it following the square? The red lines are your input. I'll make it. I hope you are, all of you may be getting on your own screen. Then let me change the value of time constant. What will happen if I'll increase the time constant? But it has become sluggish na.
Circuit
It
will
has
become, the system will become slow.
slow na. Yes, like if I increase the time constant, sorry, if I'll increase the time constant, it will. Now could you see it is not reaching to the final value in that time? Yes or no? What is the final value? 1. And if I make it very large, if you remember one property of this low pass, that filter, or a first order circuit, it is a low pass filter. So if you'll keep the time constant very high, then what is the output you'll be getting? The output will be nothing but the DC value of the input. Now if you see what is the DC value of the input presently,
0.
it is 0 na. So if I'll make it 100, so just see, this is almost around 0. Yes, if I'll make it like this, if I'll suppose uh, I make it the number of this is also large. Can you see the it is can you see the DC value? Yes, fluctuations around the DC value, yes or no?
Yes,
And
sir.
if these are the number of cycles I have denoted so that you can see better. If I'll make it a little then it will start following. Okay, now just see. Then if I'll make it 0.5, then like this 0.1, it will just follow the input. Can you see it is following the input? If I'll make still less, can you see it is following? Yes or no? Following that. So this is you can learn the behavior of the first order
Sir,
system. Yes.
sir, how you have increased the number of cycles shown in the output?
The number of cycles is from frequency.
Acha, sorry. Yes, sir.
Okay. So actually that frequency from that you can increase the number of cycles.
Yes, sir. Yes, sir. Yes, sir. I'm sorry.
No problem. So how that 10 cycles, how it is coming? Because I'm displaying 5,000, that I'm taking 5,000 samples per second, na? And how many cycles I'm displaying?
500.
5,000 samples, na? So that 10
Acha.
it will have that. Okay, for 10 seconds. Okay, so that.
Sir, actually, I have a problem, sir, with the graph.
हाँ बताओ.
When I change it to square, it is showing that sinusoidal waves. Only the triangular is matching, but means I'm not getting the.
You have not changed that earlier sinusoid actually. Simulate signal. Go to stop the program. Stop.
Okay,
Uh, I should have stopped using this. Okay. Stop the program.
okay.
Then go to the block diagram,
Yes, sir.
maximize it. Just see the sinusoid case. Now just see the simulate signal. What is the written? Sign it is written.
It is actually a triangular, sir.
So double click there.
Yes, sir.
Then go to signal type.
Yes, sir. I selected sign, sir.
Select sign and then click OK.
Okay, sir.
Okay. Now go to the next one, square.
Yes, sir.
Again see what is written.
Actually, it was different, sir. I changed it to square.
No problem.
Actually, I had changed only for the triangle, sir. Both were other two were different. I think now it
No
will be.
problem. What you do, whatever the case is the correct one. Whatever the case is the selector level you are seeing now.
Yes, sir.
Because the type of input you will be giving, the same thing will be visible in the selector level. The top the case structure top na here. Can you see?
Where, sir?
On the case structure,
Yeah.
the top,
Yes.
that can you see what is the default? What is your default?
Just a minute, sir.
Make square as your default.
Default is sinusoid, sir.
No problem. That you can again the same thing that I said now, that default value will be loaded first.
Okay.
Okay. You can change always. You can right click on the selector level and you can say make this the default case. Square waveform, right?
Okay, sir.
So now just see in the square waveform you have simulate signal. Is it showing square?
Sir,
Is
just a
it the
minute.
signal type is square in the top?
Sir, actually means still I have not changed that means default into square, sir. Sinusoid is still a default one.
No problem. That again, can you share your screen?
Sure, sir. Can you see the screen, sir?
I can see that like for sinusoid you have the correct. Now can you change it to square? Next one, yes, it is correct. Then third one, triangular. Yes, you click on that arrow on the selector level. The third one, triangular. No, back. Yeah, triangle. It is right. Now you here you unclick this on the case selector level. You right click on the case selector level where the triangular is written. Where the triangular is written, right click.
Yes, sir.
Not somewhere else you put one. I think you have to stop. Yes. Now you just see this. Go to square. Go to square. Go to square. Bus. Right click. Then you go to make rearrange cases na from bottom third towards up. Make this case default. Down. 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 Now this is your default case. Okay. Now you run. Just go to the your Now just see that it is coming. Make the time constant 0.1. It is coming. Yes. Make the frequency as 1. Okay. It is coming now.
Yes, sir.
Give me screen once back. I'll just again retry the decoration one.
Sure,
Why
sir.
it did not come that okay, I think we can stop here, and the decorations I can take beneath help, and I can inform you, right? I think that will be the great thing I can do,
Yes, sir.
because somehow I have missed that, right? So I thank you everyone to be with me for such a that long time. I hope now this I could summarize some of the things so that you could practice. Then we'll meet at 2:30 p.m. We'll meet at 2:30 p.m. for
Yes.
Dr. Gunjan, Dr. Gunjan, Dr. Gunjan Soni lecture on statistical measurement.
Okay, sir.
Okay?
Yes, sir.
And I think he will be delivering for 1 hour, and then by after 3:30, between 3:30 to 4 p.m., you'll have your that data for this your feedback. Very small feedback form it is, and then your quiz also I'll prepare by that time, right? So I thank you everyone. Then I invite all of you kindly be there in the valedictory ceremony also. It will be honor that you be there. So thank you so much.
Thank you, sir. Sir, actually, means give us a name to save this what we just did, sir.
First order system.
Okay, sir. Thank you, sir.
Yes. Thank you everyone. Bye.
Thank you, sir.
Bye.
Thank you, sir.
Thank you.